So today I'm going to talk to you about some of the work we're doing in preparing the supply chain within the UK for the transition towards low emission vehicles, but also some of the work we're doing around bringing these vehicles to market, and to give you a bit of a heads up about what might be over the horizon. So my role within Innovate UK is I'm innovation lead, so I work with SMEs, companies who are going through this or the R&D phases, and help them access finance and use that finance within their projects. So before I get started, I just want to ask you a quick question, which is, does your fleet include alternative fueled vehicles? I don't want to know about any cars you might have. I'm talking about your trucks and your vans and anything like that. So, yes or no? That is a lot higher than I was expecting, if I'm going to be honest with you. I always ask this question when I'm with fleet operators, and more often than not, the answer is no, partly because there's not a huge amount on the market yet. So, Innovate UK. So we spend about £500 million, £500 million a year on science, technology, innovation within the UK. Our sole goal is to make sure the UK remains competitive as these emerging industries come through. And so we invest in science and life sciences, health, aerospace, most areas. And if you want to talk to me about accessing some of that funding, I've got to stand outside, and I'm more than happy to spend some time in the breaks talking about it. But that's not why I've been here to speak today. I'm going to speak to you more about the type of things we do and what we have been doing over the last couple of years. So a bit about where we focus our funding, and that gives you some insight into how we've been operating. So there's the early stage R&D that goes on in universities. We're not so much interested in that. We fund things that might be on a vehicle in, say, 4 or 5 years' time, maybe slightly longer. So we're looking at something which is still within the R&D phase, so a component or whatever it might be. And then the Advanced Propulsion Centre, once our project might have finished, would take that forward and look at how you scale that. How do you make thousands of them, potentially millions of them, at the cost and the quality level required for the auto industry? So everything I'm going to talk about is probably maximum 10 years, maybe as little as 3 years away. So the type of work we are involved in, we'll talk through each of those in a bit of detail and then go into some in more detail in a moment. So connected autonomous vehicles. We see quite a lot of razzmatazz from the USA, West Coast, Silicon Valley. There's actually quite a lot happening in the UK. There's companies like 5AI and Oxbotica that don't have quite as much out there in terms of marketing and PR, but actually are working out how to make these things work with the algorithms and some of the sensors, and how to integrate those packages together. And we, as well as the technology being developed here, we're also probably ahead of the curve compared to most other countries in terms of the legislation. So when this technology arrives, whether or not the UK has much involvement in the technology itself, which we probably will, but when the likes of Bosch or Google, whoever it is, develops the final system, we should be in quite a strong and a good place to bring that into the streets of the UK relatively quickly, because we've got that legislative framework being set up as we speak. So advanced propulsion scale-up, the example we have here is the Ford Transit. So this is what I was talking about, the APC. So this is so Ford and their transit van operating in London. There's about 20 of them. This is about how do we package this plug-in hybrid solution, and how do we set up our supply chain for it within Ford's? How do they tweak the final design and make it so that it does work within real operations? And this is an ongoing live trial, and I'm sure there's people from Ford here today that you can ask about it. Low and zero emission vehicles, what we're talking about here, so many people think there's a battery and some wheels, and there's a lot that goes on in between those two components. So looking at the power electronics, the motors, the drives, and looking at how we produce those in the UK. 2.4 million engines at the moment are produced, so ICE, so internal combustion engine, and how are we going to replace those with other systems as they come through. We also look at other alternatives. Is particularly relevant, I think, for the freight industry, so potentially hydrogen and some of the pressure vessels and the designs around that and the engines themselves. Looking at gas, so whether it's biogas or compressed natural gas or liquefied natural gas. Looking at some of the hybrid solutions as well. Lightweighting, which is another really important subject, I think, for this room as well. Next one's a Faraday battery challenge. I'll talk a bit more now in a moment. The next one is around vehicle to grid. So this is potentially using that, so rather than the battery being a concern for the grid, so all of these batteries needing to be charged at the same time, how will the grid cope, flipping that over and saying, actually, all these batteries attached to the grid, how do we make use of that? How do we turn that into an asset rather than a liability? And then we've got the niche vehicle network, so I think some of the vehicles you might see on Top Gear that are British made, like Noble and Delta and people like that, a lot of their funding or some of their funding to develop these systems come through the niche vehicle network. And then reducing emissions from freight, which again I'll talk about in a bit more detail in a moment. So the Faraday battery challenge, as I mentioned before, 2.4 million engines being produced in the UK at the moment, and we need to replace those. Quinton mentioned 2040 targets the government has. We don't want to lose that supply chain from the UK. So this, I suppose, ultimately, success will be if we can anchor some of these gigafactories that will be popping up in the coming years. In Europe, we're probably going to need somewhere in the region of 30 gigafactories, huge battery factories pumping these things out to meet the requirements of the industry. And success of the Faraday battery challenge, and quite a lot of funding there, will be a number of those in the UK. So again, going through those 3 different stages I was telling you about, so we're funding fundamental research into the chemistry, what that might look like, and how do we get the weight savings that we need. So this, we're thinking about probably 2030 for some of that research to come to fruition. And so things like the Tesla truck you might see, this is where that type of research, how you get the battery, the energy densities down and things like that. We're thinking about our work, it's more about, so we've got some chemistry, how do we make that actually work in the real world? How do you prototype that so that it really works? And then the scale-up facility is about, right, we've made something that's really good chemistry, it's cheap, it's got 0 rare earth materials, it's good for the circular economy, etc., etc. How do we make millions of those at scale? And that's what the scale-up facility is all about. So another big work area for us at the moment is a low emission freight trial. We have got 18 projects, 22 million total funding. These vehicles are hitting the road now. Some of them are already on the road, some of them will be on the road by the end of the summer. They're going to spend a year in real operations with real operators that we hope will try and break them. That's the idea of this. We want them to use them, abuse them, feed back to us what is the problem, to feed back to the companies that are producing this technology, what is it that doesn't work and what is it that does work. And I think there's 2 elements to that really. So one is that trial and that demonstration. So whether it's a new hybrid system or whether it's a sensible new TRU system, or if it's some pure electric variants, or if it's the way in which the vehicle is charged. Or there's some demonstrations of the technology. This is more at scale. This is more about getting 10s or 20s of, for example, gas trucks into fleets. How do they work when you potentially change more than half of a depot over to a different type of fuel? So the 2 that I really want to focus on here, which I think is of most interest to the audience, one is the Camden depot project. So this one is been really involved for UPS, and it has, so they know that they can charge about 50 vehicles in their depot with their current setup, but they've got 170 vehicles they're going to need to charge in their depot in the coming years. So how are they going to do that without having to spend millions of pounds on grid upgrades on an asset that they don't own? If they move depots, they lose that asset. What can they do to de-risk that, to make that a bit cheaper for them? And so our project, the project we're doing with them, is involving a number of different smart solutions. So there's a battery on site, a big battery that can be used to charge the vehicle rather than using the mains, and that can then charge up more slowly during the off-peak times. Smart charging technology that stages when the vehicles charge. So rather than them all charging as soon as they get home at 6 in the evening, they charge through the night, so they just need to be ready for 7 in the next morning, for example. And then also some minor alterations to the grid that allow you to utilize more of that energy. So that was very involved for UPS. It's still ongoing. They're going to learn a lot from that. It's taken them a number of years working with UK Power Networks, working with their energy supplier. These are things that have never been done before. And working through these has been very involved for them and difficult. But they're going to provide learnings, but ultimately they're going to take a lot of learning from that to roll that type of solution out into other depots. Another one I want to talk to you about is John Lewis Partnership and their work with CNG Fuels. So this is, and there's people from John Lewis Partnership in the room, and I think CNG Fuels as well, that I'm sure you can speak to in more detail about this. I checked with them beforehand, and they are happy to speak to you about it, and they're very positive about the project. But broadly speaking, they have ambitions to stop buying diesel trucks. And what they needed to know, and this is my words, not theirs, so they might change this slightly, but what, as far as I could tell, they needed to know was, if we don't use diesel, how do we make sure that these vehicles, if something goes wrong, will continue to be able to operate? Because if your diesel fueling station in your depot or whatever it is stops working, there's enough diesel nearby. But if your CNG fueling station goes down, that's it. Groceries aren't going anywhere. So this project is from CNG Fuels is about really building a very robust refueling infrastructure so that there's enough confidence that they can replace all of their vehicles with gas. And in their case, they're using the certificates that allow them to say they're using pure biogas. There's still question marks over the sustainability of gas and where we want to focus that. So I don't want to talk too much about that today. So those are a couple of projects, a couple of examples, both of them very involved. They weren't like flicking a switch. It wasn't suddenly, okay, I want electric, tomorrow I can have electric. That's not how this works. So the final thing I really want to leave you with is that in the coming years, again, Quinton touched on this, there's clean air zones coming. There's Metro mayors that want to state their case. There's the London mayor, there's DEFRA, there's legal challenges. At the moment, we know Euro 6, broadly speaking, will be okay. Who knows in the future? There's also CO2 targets. At the moment, CO2 targets are sort of voluntary. In the coming years, you'll probably be asked to sign up to something. Again, that could change. So that's the one side. That's the stick almost. And the other side of it is that John Lewis Partnership won't mind me saying this, that they potentially see savings in this, monetary savings in this. The same with using electric vehicles. If the cost can come down, electricity is a hell of a lot cheaper than diesel, sorry. So if the cost of the vehicles can come down, then there's some real savings to be had here. Now, what happens when one or both of these happen and you aren't ready for it? You haven't done the R&D and you haven't tested how these vehicles work in your fleet. And suddenly your competitors have got a whole fleet of electric vehicles, for example, or gas vehicles. And your customers are saying, well, I'm going to go with them, thanks, because they already nailed this technology. It's not easy. It's a different operating model. You can't flick a switch. Trials and demonstrations, I think, are business critical. And that's the message I want to leave you with today. So thank you very much. And I've got one more question for you, which I hope will pop up behind me. So I'm interested to know, of the fleet managers here, do you plan to trial alternative fueled vehicles as they come to market? And it's a simple yes, no. So yeah, go for it. Okay, that's interesting. I think that's That's higher than I was expecting, so I'm pleased to see that. Those 22% of you that say no, please come and speak to me afterwards. I think it's important that we change that. Yeah, so thank you very much.
Thank you, Ben. Okay, so a question here. To ensure that we remove the probables in air quality, especially in relation to Euro 6 engines, what can I do to be proactive?
So I think, first of all, first thing to say is that that vehicle there, they are Euro 6. And when you're talking about Dieselgate and things like this, it's important to make a distinction between those vehicles under 3.5 tons and those vehicles over 3.5 tons. The vehicles over 3.5 tons, the manufacturers have done a fantastic job in reducing the air quality related emissions there. And we know that, we've tested these things, and diesel Euro 6, VI Euro 6 over 3.5 tons are fantastic. That's the first thing to say, and it's important to note that. I think that there's because of that, there's two things. There's Euro 6 and there's 0. I don't think there's much in between. So when we're talking about next things that might be coming onto the market, we're talking about them being 0 emission, and that's from the air quality point of view, I think. So yeah.
Okay, next question, which follows on to what you just said. I can't afford to constantly change my fleet to lower and lower emission vehicles because of the cost.
Yes.
How do I protect myself by making the right decisions now for the future?
Yeah, I think that first of all, again, Euro 6, I'm speaking to colleagues at DEFRA, I can't speak for DEFRA, but my understanding is this won't change. Euro 6 trucks are Euro 6 trucks. I don't think there's anything coming anytime soon that's going to change these low emission zones around that. I think what I can say at the moment is that you should be trialling and demonstrating a few other types of vehicles in your fleet. I'm not advocating or suggesting that changing your entire fleet away from a Euro 6 diesel at this stage is a sensible thing to do. All I'm saying is you need to be having some of these vehicles and at least have a plan or a process in place by which you're ready, so that when the switch does happen and when changes do come in, which 5 years' time perhaps, you're ready for them. So I think that's what I would say.
Great. Okay, Ben, please show your appreciation.